All right, yet another rocket problem, right? So 16 kilograms, our initial mass then is 16 kilograms, right? Our final mass is what? 16 minus 12 is 4 kilograms, right? So it starts off 16, ends up with 4 kilograms, right? Okay. And then we can find the thrust of the rocket engine, right? I'm using force times time is mass change in velocity, right? So the force times, and then it's kilograms per second, right? So I say kilogram per 1 second. So I put 1 in for the time, and then I go 0.382 kilograms. And then our exhaust velocity is 642 meters per second, right? So whenever they give you kilograms per second, that just means that the mass is that and the time is 1 second. Okay, just put 1 second in there, right? So 0.382 times 642 is 245.244. Okay, so the force is 245.244 newtons. All right, so now we're all set. Now we can find the initial acceleration. Right here we got the rocket. This is rocket science after all. The force up is 245.244. Right, the force down, well, let's see, at first we got 16 kilograms, right? So the force down is 16 times 9.8. I got 156.8, right? So this is positive, this guy's negative because it's down. I'm going to use F equals ma. Right, so our forces are 245.244 minus 156.8 is equal to 16 times A. All right, so here we go. So that guy minus this guy. I'm just going up arrow on my calculator. It's kind of fun. I get 88.444. Okay, divided by 16. Ooh, that should be fun. Ooh. I get the acceleration, the initial acceleration is 5.52775, right? Or actually 5.53, basically, meters per second squared. So the answer's off just a little bit, but that's okay. Okay, now if we do the final, if I do the final acceleration, I got to put a colon there, right? Final thing, the only thing that's changed is that now we've got the same rocket, same upward force, right, of 245.244, right? But the down, we only have 4 kilograms. So the downward force is 39.2, right? Right, that is 4 times 9.8. That's that devilry there, right? So multiply 4 by 9.8, 39.2. That's positive. This guy's negative. Again, we're going to do F equals ma. So 245.244 minus 39.2 is equal to 4. So don't forget to change. Here it's 16 there, right? This one's 4, right? Times A, right? So 245.244 minus the answer I just got. That's 206.044, and I'm going to divide by 4. 51.511. So whoops. Ta-da. All right. So again, find the initial mass, the final mass. Find the thrust of the rocket engine using force times time as mass change in velocity. If they give you kilograms per second, make it 1 second for the time and that many kilograms, and you've got it set, right? And then go delta V is like that, right? And just put the delta V in there. The exhaust velocity is the delta V, and you're good.